The Linux world has always moved forward quietly, steadily, and sometimes unexpectedly. But every now and then, a release arrives that makes the entire tech community stop and pay attention. The release of Linux Kernel 7.0 is one of those moments. For decades, the Linux kernel has powered everything from tiny embedded devices to the largest supercomputers in the world. And each new version continues that evolution. With Linux Kernel 7.0, the project crosses another symbolic milestone, but more importantly, it introduces improvements that affect performance, security, hardware compatibility, and the future direction of open-source computing. For many people, the kernel is something invisible, something that simply works in the background of their operating system. But in reality, the kernel is the heart of Linux. It is the layer that connects software to hardware, manages memory, controls processes, handles device drivers, and makes sure that everything running on a Linux system communicates correctly with the underlying machine. The journey to Linux Kernel 7.0 did not happen overnight. It is the result of thousands of developers from around the world contributing code, reviewing patches, fixing bugs, and improving performance over many development cycles. The Linux kernel development model is unique compared to most software projects. Instead of being controlled by a single company or a small team, it is a massive global collaboration led by Linus Torvalds and maintained by hundreds of subsystem maintainers. Every release cycle brings thousands of commits and changes, and Linux Kernel 7.0 is no different. In fact, the scale of development behind this release shows just how powerful the open-source ecosystem has become. Major technology companies like Intel, AMD, Google, Red Hat, Canonical, and countless others contribute to the kernel because their products depend on it. At the same time, independent developers and volunteers continue to improve the system simply because they believe in open software. One of the biggest themes of Linux Kernel 7.0 is hardware support. As technology evolves, new processors, GPUs, storage devices, and networking hardware appear constantly, and the Linux kernel must adapt to support them. In this release, developers have significantly improved compatibility with the newest generation of processors from both AMD and Intel. Modern CPUs include complex features like advanced power management, hybrid architectures, and hardware-based security technologies. Kernel 7.0 includes updates that allow Linux to take full advantage of these capabilities. This means better power efficiency for laptops, improved performance for servers, and smoother operation for desktop users. Hardware enablement is one of the reasons Linux has become so widely used across industries. When new chips are released, kernel developers often work closely with manufacturers to ensure Linux supports them as soon as possible. Another area where Linux Kernel 7.0 shines is performance optimization. Over the years, Linux has earned a reputation for being extremely efficient, but developers continue pushing the limits of what the kernel can do. Improvements to the scheduler, which is responsible for deciding how CPU time is distributed among processes, allow systems to handle workloads more intelligently. On multi-core systems, this becomes especially important because the scheduler must decide which core should run which process and when. In Kernel 7.0, these decisions have become more efficient, reducing latency and improving responsiveness in both server and desktop environments. For cloud providers running thousands of virtual machines, even small improvements in scheduling can translate into massive gains in overall system efficiency. Memory management is another critical part of the kernel that has received attention in version 7.0. Modern applications use enormous amounts of memory, and the kernel must manage that memory carefully to avoid slowdowns. Linux already uses advanced techniques like memory compression, swap management, and page caching to ensure that systems remain responsive even under heavy workloads. In this new release, developers have refined several of these mechanisms, improving how the kernel handles memory pressure situations. The result is better stability when running memory-intensive workloads like large databases, virtualization platforms, and high-performance computing applications. These improvements are particularly important in data centers where thousands of processes compete for resources simultaneously. Security has always been one of the most important priorities for the Linux community, and Linux Kernel 7.0 continues to strengthen that focus. As cyber threats evolve, operating systems must constantly adapt to defend against new attack methods. Kernel developers have introduced additional hardening features designed to reduce the risk of vulnerabilities being exploited. Improvements to sandboxing technologies help isolate applications so that even if one program is compromised, it cannot easily affect the rest of the system. Security modules like SE-Linux and AppArmor also benefit from kernel improvements, giving administrators more tools to enforce strict access controls. Another key area of security development involves memory safety, where the kernel works to prevent bugs that could lead to privilege escalation or remote code execution. One of the most exciting ongoing developments within the Linux kernel is the integration of the Rust programming language. While the majority of the kernel is still written in the C programming language, Rust support has been gradually expanding. Rust is known for its strong memory safety guarantees, which help prevent common bugs such as buffer overflows and use-after-free errors. Linux Kernel 7.0 continues building on earlier work by expanding the infrastructure needed to write kernel components in Rust. Although Rust code still represents a small portion of the overall kernel, many developers believe it will play a significant role in the future of Linux. The goal is not to replace C entirely, but to allow new drivers and subsystems to be written in a safer language when appropriate. File systems are another important part of the Linux kernel, and version 7.0 introduces updates to several major ones. File systems determine how data is stored and retrieved from storage devices, and improvements here can have a major impact on performance and reliability. Popular file systems like X4, Btrfs, and XFS continue receiving optimizations that make them faster and more resilient. Btrfs in particular has seen ongoing improvements aimed at making it more stable for enterprise workloads. Meanwhile, the kernel also continues supporting emerging storage technologies such as NVMe drives, which provide extremely high speeds compared to traditional hard drives. Linux Kernel 7.0 includes enhancements that help systems take better advantage of these high-performance storage devices. Networking capabilities in the Linux kernel have also advanced significantly in this release. Linux already powers a large portion of the world's internet infrastructure, including routers, servers, and cloud platforms. Kernel 7.0 introduces improvements to network stack performance, allowing systems to process packets more efficiently and reduce latency in high-traffic environments. For data centers and cloud providers handling millions of network requests every second, these improvements are critical. Developers have also continued expanding support for advanced networking technologies such as high-speed Ethernet, modern wireless standards, and improved virtualization networking features. Another interesting aspect of Linux Kernel 7.0 is its continued focus on energy efficiency. As computing expands into mobile devices, laptops, and energy-conscious data centers, reducing power consumption becomes increasingly important. Kernel developers have worked on optimizing power management features so that CPUs, GPUs, and other components can dynamically adjust their energy usage depending on workload. This means laptops running Linux can enjoy longer battery life while servers can reduce electricity consumption in large-scale deployments. Energy efficiency is not just about saving power. It also contributes to sustainability by reducing the environmental impact of computing infrastructure. Linux Kernel 7.0 also reflects the growing influence of Linux in areas beyond traditional desktops and servers. Today, Linux powers smartphones, smart TVs, embedded devices, industrial systems, and even vehicles. Automotive companies use Linux-based platforms for infotainment systems and autonomous driving technology. Smart home devices rely on Linux to manage sensors and connectivity. In industrial environments, Linux runs on machines controlling manufacturing processes. With each new kernel release, developers ensure that these diverse platforms remain supported and capable of handling modern workloads. Kernel 7.0 continues expanding support for embedded hardware and specialized architectures, ensuring Linux remains adaptable across countless use cases. Another key factor behind Linux's success is its modular design. Instead of forcing every system to include the same features, the kernel allows components to be loaded or removed depending on the needs of the system. This flexibility makes Linux suitable for everything from tiny IoT devices to massive supercomputers. Linux Kernel 7.0 further refines this modular architecture, making it easier for developers to maintain drivers and subsystems independently. This approach helps keep the kernel maintainable despite its enormous size and complexity. The community behind Linux is perhaps the most remarkable part of the project. Thousands of contributors from different countries, companies, and backgrounds collaborate to build and maintain the kernel. Some developers focus on specific subsystems like networking or storage, while others specialize in architecture support or performance optimization. Every change goes through a rigorous review process to ensure quality and stability. Linux Kernel 7.0 represents the combined effort of this massive global community working toward a shared goal. It demonstrates what open collaboration can achieve when people from across the world contribute their expertise. For desktop Linux users, the impact of Kernel 7.0 may appear subtle at first. The graphical interface, applications, and overall user experience are primarily handled by the distribution and desktop environment rather than the kernel itself. However, improvements at the kernel level eventually translate into smoother performance, better hardware compatibility, and improved system reliability. When users plug in new hardware and it works instantly, or when their system remains stable under heavy workloads, the kernel is quietly doing its job behind the scenes. For developers and system administrators, the release of a new kernel version is always exciting. It brings new capabilities that can be leveraged in servers, containers, virtualization platforms, and development environments. Technologies like containers rely heavily on kernel features such as namespace and control groups. Improvements in these areas can enhance the performance and isolation of containerized applications. Linux Kernel 7.0 continues refining these mechanisms, helping platforms like Docker and Kubernetes operate more efficiently. Another significant trend reflected in Kernel 7.0 is the increasing importance of Linux in artificial intelligence and machine learning workloads. Many AI frameworks run on Linux because of its flexibility and performance. GPU drivers, high-speed networking, and advanced memory management are all essential for training large models and processing massive datasets. Kernel improvements that optimize these areas can directly impact how efficiently AI workloads run. As AI continues to grow, Linux will likely remain the dominant platform for researchers and organizations developing advanced machine learning systems. The release cycle of the Linux kernel typically follows a predictable pattern. After a new version is released, a merge window opens where developers submit major changes for the next version. This is followed by several weeks of testing and bug fixing through release candidates before the final version becomes stable. Linux Kernel 7.0 represents the culmination of one of these cycles, bringing together countless improvements that have been tested and refined by the community. The process ensures that each release maintains the stability that Linux is known for. While version numbers can sometimes create the impression of a dramatic transformation, the Linux kernel evolves through incremental progress rather than sudden revolutions. Linux Kernel 7.0 is not a completely different system compared to previous versions, but it represents thousands of small improvements that collectively make the operating system stronger. Each optimization, bug fix, and new feature contributes to a more capable and reliable platform. Looking ahead, the future of Linux kernel development remains incredibly active. Developers are already working on features that may appear in future releases beyond 7.0. Areas like improved security hardening, expanded Rust integration, better real-time capabilities, and enhanced hardware acceleration will continue shaping the kernel's evolution. The open-source nature of Linux ensures that innovation can come from anywhere. Whether it's a large corporation improving support for its hardware or an independent programmer fixing a bug they encountered, every contribution helps push the project forward. Linux Kernel 7.0 ultimately represents more than just a software update. It symbolizes the ongoing success of open-source collaboration and the importance of community-driven development. In a world where many technologies are controlled by a small number of corporations, the Linux kernel stands as a reminder that powerful software can be built collectively by people around the globe. From smartphones to supercomputers, Linux continues to power a huge portion of modern technology infrastructure. With each release, the kernel becomes faster, more secure, and more capable, ensuring that Linux remains one of the most important operating systems in the world. As Linux Kernel 7.0 begins appearing in major distributions, users will gradually experience its benefits without necessarily noticing the complex engineering behind it. Systems will boot faster, hardware will work more reliably, workloads will run more efficiently, and security protections will continue strengthening. The kernel remains the invisible foundation of the Linux ecosystem, quietly enabling everything that runs above it. And while version 7.0 marks another milestone in the project's history, It is also simply another step in the long journey of Linux development, a journey that continues shaping the future of computing across the entire world.